In this lecture video, we are going to start topic 5, which is on the conservation of energy. The conservation of energy is the idea that energy in an isolated system can neither be created or destroyed. So the amount of energy that you start with has to be the same amount of energy you end with in a closed system. However, energy can be changed from one type of energy to another. In order to do that, you must do work on the object. So work leads to a change in energy. So before we can talk further about the conservation of energy, we need to discuss what exactly work is. Because work means something different in everyday language. When I'm teaching a face-to-face class, I usually make a joke that I'm at work right now. But that doesn't mean that I'm doing work in terms of the way a physicist might define it. So work is when an object is moved through a displacement while a force or more than one force is applied. However, it's not just any old force and any old displacement. In order for work to occur, the force and displacement must be parallel to each other. So work is going to equal force set in the x times the change in x, or work is going to equal force set in the y times the change in y. You cannot mix x's and y's. So if you apply a force in the x but end up moving it in the y direction, according to a physicist, you've done no work. So if you imagine a bodybuilder crunched down holding up a massive set of weights, person sweating and everything, but according to a physicist, that person is not doing any work. It isn't until the bodybuilder actually lifts the weights up, so applying a force against the force due to gravity in the y direction, so the force and the displacement are parallel to each other, that's when the bodybuilder actually does work. So you have to remember, work in terms of physics and work in terms of the way we use it in everyday language is not the same thing. This also means that you can't forget about topic 4. Topic 4 is going to allow you to be able to establish what force set in the x is, because you're summing forces in the x direction using Newton's second law, or summing forces in the y direction. So you're applying Newton's second law in the y direction. So you have to remember that you're taking material from topic 4 and applying it here in topic 5. We are going to learn a new unit, and this is going to be a big unit in this particular topic because the unit for work is going to be joules. Joule discovered the conservation of energy, and a joule is the same thing as a kilogram meter squared per second squared. And because work causes a change in energy, work actually equals the change in energy, they are going to have the same units. So both the units for any type of energy we talk about in this topic and work is both joules. Work is a scalar quantity. However, it still can be negative and positive, but the negative and positive does not indicate direction. Instead, it indicates whether or not energy is decreasing or increasing.